Hello friends, welcome to my channel GATEquestionsECE. So the next question on discrete random variables is the question with question code 103. Consider two uniformly distributed independent discrete random variables x1 and x2 such that x1 is uniformly distributed over 0 to 3 and x2 is uniformly distributed over 0 to 2. Then find the following probabilities. First probability is probability that x1 plus x2 is less than equal to 0. So we have to find this. Second part is probability x1 minus x2 is greater than minus 1. So we will have to find this also. So firstly I will solve both these problems by following a standard procedure which we usually use in such type of question. And in the last of this video I will give you a shortcut technique to directly find these probability from the joint distribution of x1 and x2. So firstly let's see the standard procedure of solving such questions. So it is given in question that x1 is uniformly distributed over 0 to 3 and x2 is uniformly distributed over 0 to 2. So it means x1 can take values 0, 1, 2, 3 and corresponding probabilities will be 1 by 4, 1 by 4, 1 by 4 and 1 by 4 for all these 4 cases. Similarly, x2 can take values 0, 1 and 2 and corresponding probabilities will be 1 by 3, 1 by 3 and 1 by 3 for these 3 cases. So in the first problem he has asked about the probability x1 plus x2 is less than equal to 0. So in such problems where there is sum of two independent random variables, we use the method of convolution. In such problems, we consider that x1 and plus x2 is another random variable, say z. And we know that if x1 and x2 are independent, then the p.m.f of z is convolution of p.m.f of x1 and x2. So the p.m.f of z will be equal to the discrete convolution of p.m.f of x1 and x2. So by the tabular method we can find what will be the p.m.f of z. For that we draw a table here and write down x1 on this side and x2 on this side and corresponding values and their probabilities. So x1 can take values 0, 1, 2, 3 and corresponding probabilities are 1 by 4, 1 by 4, 1 by 4 and 1 by 4. Similarly x2 can take values 0, 1 and 2 and corresponding probabilities are 1 by 3, 1 by 3, 1 by 3. Then we multiply all these 4 elements with the first element here 1 by 3. So the answer will be 1 by 12 for the first row. Similarly for second row we multiply this element with all the 4 elements here. So the answer will be same 1 by 12. So we can see that all the elements here will be 1 by 12. So we will be having 12 elements here, each with value 1 by 12. So now we draw here diagonal lines in this table. You can observe here that this element here. For this element, the value of z is 1. I am writing here with red pen. So this element here has value of z as 1. Similarly here, this element has value of z as 0 plus 1. So this element has value of z as 1. Similarly, this element here has value of z as x1 here is 0 and x2 is 0. So 0 plus 0 is 0. So we are keeping those elements for which z is same in the same diagonal. So this diagonal has all elements for which z is 0. It is having only one element. In this diagonal, we are having all the elements for which z is 1. So both these elements have z is equal to 1. Similarly, in this, we can see for this element, the z will be 2 plus 0. So it will be 2. Similarly, you can see here for this element, the value of z for this element will be 1 plus 1. So it will be 2 again. Similarly, for this element, you can see its value of z will be 2. So diagonally, we are having those elements which are having same value of z. So finally, we add these elements to get the p.m.f of z. So we can see here that z can have value 0, 1, 2 and 3 for this diagonal, 4 for this diagonal and 5 for this diagonal. So up to 5 and last value will be 5. So the corresponding probabilities of z is equal to small z will be, here only one element is there, so the answer is 1 by 12. Here for z is equal to 1, we have to sum these two elements, so the answer is 2 by 12. For z is equal to 2, we can see here we are having 3 elements, so the corresponding probability will be 3 by 12. Similarly, these 3 elements we add up and answer is 3 by 12. For z is equal to 4, we add these 2 elements, so the answer is 2 by 12. And for z is equal to 5, there is only one single element, so the answer is 1 by 12. So now we have the p.m.f of z. So our question is now reduced to probability. Here x1 plus x2 is z. So z is less than equal to 0. You can observe here that there is only one non-zero probability for z is equal to 0, which is satisfying this equation. Because for all the values of z less than 0, there is no non-zero probability. So this probability will be equal to probability z is equal to 0. So which is nothing but 1 by 12. So this is the answer to our first problem. Probability x1 plus x2 is less than equal to 0. So this is how you handle whenever in question they ask about the sum of two random variables. So now let's see how to handle part B. So in the B part, it's asked to find the probability x1 minus x2 is greater than equal to minus 1. So similar to part 1, we can find it by assuming this x1 minus x2, the difference between x1 and x2, as another random variable z. So this probability will become probability that z is greater than equal to minus 1. So we can write z will be equal to x1 minus x2. So similar to part A, we know that for the difference of two random variables, the resultant random variable will have p.m.f, which will be equal to the discrete convolution of p.m.f of x1 and p.m.f of reversed x2. I will write down here. We know this, that the p.m.f of Z will be equal to discrete convolution of p.m.f of x1. So this p.m.f, this is the p.m.f of x1 that I have drawn here, and we have to convolve this p.m.f with the reversed p.m.f of x2. So similar to discrete signals, we have to take its reversal here about origin, and after taking the reversal of p.m.f of x2, we will have to convolve the reversed p.m.f with this p.m.f. So discrete convolution of p.m.f of x1 with p.m.f of x2 reversed about origin. So we can plot here the p.m.f of x2 reversed about origin will be, it will look like this. So here it is x2. So this, when reversed about origin, it will, this 2 will go to -2, and the corresponding probability here it is 1 by 3. So it will become 1 by 3. This 1 will reverse to -1, and its probability is 1 by 3. This 0 when reversed to, it will become 0 again, and probability is 1 by 3. And probability here is 0. So -1 when reversed, when negated, it will become +1, and probability will remain 0. So this is the probability of -x2. So this is the reversed probability. So now we will convolve this p.m.f with this p.m.f. That we can do with the tabular method. So I will write x1 on this side, and on this side I will write -x2, reversed sequence of x2. So x1 can take values 0, 1, 2 and 3, and the corresponding probabilities are 1 by 4, 1 by 4, 1 by 4 and 1 by 4. Similarly, this reversed sequence -x2 can take values -2, -1 and 0 for non-zero probability. So I will write here only for non-zero probability. Its value can be -2, -1 and 0. The corresponding probabilities are 1 by 3, 1 by 3 and 1 by 3. So multiplying this element with all the 4 elements, we get 1 by 12 here. Again 1 by 12. So you can observe that all the 12 elements in this table will be again 1 by 12. So now you can make the diagonals. You can quickly write here what will be the value of z for all the elements here, and you can observe that for this element z will be -2 plus 0, so it will be -2 for this element. And for this element here it will be -1 plus 0, so it will be -1 for this element. Similarly for this element it will be -2 plus 1, so it will be -1. So both these elements here are having same value of z, -1 here and -1 here. Similarly for these three elements you can calculate that the value of z will be 0. For these three elements value of z will be 1. For these two elements value of z will be 2, and for the last element here value of z will be 3. So we can write here that z can have values from -2 to -1, 0, 1, 2 and last value will be 3. And corresponding probabilities you can get by adding the diagonal elements. So here it is 1 by 12. Only one element is here. For this, there are two elements. So 1 by 12 plus 1 by 12 will be 2 by 12. For 0, you can observe there are three elements here. So it will be 3 by 12. For 1, again 3 elements. So it will be again 3 by 12. For 2, there are only these two elements. So it will be 2 by 12. For the last element, it will be 1 by 12. So now he has asked probability that z is greater than or equal to minus 1. So this probability that z is greater than or equal to minus 1 will be equal to probability that z is equal to minus 1 plus probability that z is equal to 0 plus probability that z is equal to 1 plus probability z is equal to 2 and last probability that z is equal to 3. So you add all the probabilities for values greater than or equal to minus 1. So when we add all these five probabilities, you can observe we will get answer will be equal to 11 by 12. So this is the answer to this question. So the probability that x1 minus x2 is greater than or equal to minus 1 will be equal to 11 by 12. So this is the standard procedure of handling the sum of two random variables or difference of two random variables. In sum or difference of two random variables, we use discrete convolution method as a standard procedure to solve such type of questions. Now I will give you shortcut technique to find the sum and difference of two random variables using joint p.m.f of x1 and x2. So let's see that shortcut method. So this is given in question that x1 is distributed uniformly over 0 to 3 and x2 is uniformly distributed over 0 to 2. So we can write joint probability of x1 is equal to x1 comma x2 is equal to x2 will be equal to the product of marginal probability, because here x1 and x2 are independent random variables. So this will be equal to, in all the four cases it is 1 by 4. It will be 1 by 4 into 1 by 3 for all these three cases. So it will be equal to 1 by 12 for all the 4 into 3, 12 points. So for all these 12 points that I have plotted here in x1 x2 plane, the joint probability of occurring of each point in this x1 x2 plane is 1 by 12. So he has asked in part A probability that x1 plus x2 is less than or equal to 0. So if you can see in this x1 x2 plane, I have already plotted a green line here, which you can see that this line is x1 is equal to minus x2 line, or x1 plus x2 is equal to 0 line. So any point lying on this line in this x1 x2 plane will satisfy x1 plus x2 is equal to 0. And similarly you can see this region that I have drawn with blue lines, this whole region of blue lines that is lying below this green line, this region is the region that satisfies x1 plus x2 is less than 0. So the region in x1 x2 plane that satisfies this equation x1 plus x2 is less than or equal to 0 is the region that includes this green boundary x1 plus x2 is equal to 0 and this blue region x1 plus x2 is less than 0. So this probability is the probability, it is the probability that x1 and x2 jointly lies in region x1 plus x2 is less than equal to 0. So this probability will be equal to sum of all joint probabilities lying in region x1 plus x2 is less than equal to 0. So sum of all such joint probabilities that are lying in this region will be equal to this probability. So we can see here that there is only one point out of all these points, there is only one point that is lying in our desired region, x1 plus x2 is less than equal to region. As there is only one point lying here, which is lying on this line, and no point out of these point is lying in this blue region. So this probability will be directly, we can write it will be equal to joint probability of this point. So joint probability of this point is 1 by 12. So all we have to do in this shortcut technique is to draw the joint probability distribution of x1 and x2, and then find out all the points that are lying in our desired region, that is asked in question, and then sum up the joint probabilities of all those points that are lying in the desired region. So that will give you the probability that is asked. So now we will use same shortcut method to find the B part of this question. So let's see its solution. So in the B part, we are asked about probability that x1 minus x2 is greater than equal to minus 1. So firstly we need to identify what is this region in this x1 x2 plane. For that, firstly we will identify what is this line itself is equal to minus 1. So this line in x1 x2 plane is the line that I am going to draw now. So this line is x1 minus x2 is equal to minus 1 line. The region that is lying above this x1 minus x2 is equal to minus 1 line, this whole region that is lying above this x1 minus x2 is equal to minus 1 line is the region which satisfies x1 minus x2 is less than minus 1, and the region that is lying below this line, this whole region is the region that is satisfies x1 minus x2 is greater than minus 1. So our region of interest according to this question is the region that includes this boundary as well as the region that is lying below this line. So we can see out of these 12 points, these 11 points are lying in the region of our interest. So we will sum up the joint probabilities of these 11 points, and that will give us this probability. So the sum of joint probabilities of these 11 points will be, we can directly write it will be 11 by 12. So answer will be 11 by 12. So I hope you will save lot of time in the exam by using this shortcut method. You can save lot of time in exam, and you have learned this shortcut method, and it has improved your knowledge of how to handle such probabilities in GATE exam. So thank you for watching this video, and please do subscribe my channel.